You know, we hear the word average thrown around all the time. The average salary, the average temperature, you name it. But what does it really mean? Well, it turns out that simple little word can be surprisingly misleading. So today, let's pull back the curtain on average and see what's really going on, using a simple classroom example.
Okay, so picture this. You're in a college classroom. If I asked you to figure out the typical age of a student in there, how would you go about it? Seems pretty simple, right? Well, let's take a look at the actual ages and see what happens.
All right, so here they are, the ages of the 20 students in our class. It's just a jumble of numbers, right? To make any sense of this, we really need one single number to represent the whole group. And, you know, our first instinct, the thing we all learned in school, is to find the average.
And that, of course, brings us to our first tool, the mean. Now, this is what most people are talking about when they say average. I mean, this is the workhorse of statistics. And honestly, it's popular for a good reason.
The whole idea behind it is pretty straightforward. You just add up every single number in the set, and then you divide by how many numbers you have. The key thing to get here is that every single data point, from the very lowest to the very highest, gets included in that final calculation.
Okay, let's actually run the numbers for our classroom. Step 1, we add up all 20 of those ages, and that gives us a grand total of 475. Step 2, we just divide that sum by the number of students we have, which is 20.
And boom, that gives us a mean age of 23.8 years. There you have it. Problem solved. The typical age in the classroom is 23.8. Or is it? Okay, but this is where the story gets interesting, because it turns out just one number can completely change the story and paint a picture that isn't quite accurate.
So let's just pause for a second and use our gut check here. Think back to that list of ages, all those 20s, 21s, and 22s. Does an average of almost 24 really feel right to you? Something seems a little off.
And here's why it feels off. When you actually look at the data, it's pretty clear. Most of our students are all clustered together on the left, right there in their early 20s. But then you look way, way over on the right. Yep, we have one student who is 65 years old.
Right, so this lone data point, this is what statisticians call an outlier. It's a value that's just way out there, far away from everybody else. And because the mean has to include every single number, that one big age, 65, is acting like an anchor, pulling the entire average up and away from where most of the students actually are.
So what do? Is the mean useless here? Not at all. We just need different tools for the job. And thankfully, we've got a couple more in our toolkit. So let's meet the median and the mode. Okay, so this is the absolute key difference you got to remember. The mean is all about the value of the numbers. That 65 carries a ton of weight. The median, though, it's all about position. It couldn't care less how high or low the extreme numbers are, only where they sit in line.
So with the median, the first thing you always have to do is line up all your data points in order from smallest to largest. The median is simply the number that's sitting smack dab in the middle of that line. Half the data is below it, and half the data is above it. Simple as that.
All right, so let's actually do this for our classroom. First, we put all the ages in order. Now, since we have an even number of students, 20, there isn't one single middle number. So what do? Easy. We just take the 2 in the middle, which are the 10th and 11th students. Their ages are 21 and 22. We add those together, divide by 2, and we get a median of 21.5 years.
And here's the magic of the median. It comes out to 21.5, which feels a lot more representative, doesn't it? Now notice something. That 65-year-old student, it didn't matter at all. Whether that person was 65 or 165, the middle numbers would still be 21 and 22. The median basically ignores the outlier.
And then we have the mode. Honestly, this one's the easiest of the bunch. It is simply the number that shows up most often. If you look at our list, the age 20 appears 5 times, more than any other age. So our mode is 20. It just tells us the most common value. That's it.
Okay, let's recap. We've got a mean of 23.8, a median of 21.5, and a mode of 20. 3 different numbers all calling themselves average. So why are they so different? Well, the answer is all about the shape of our data.
You see, in a perfect, statistically beautiful world, our data would look something like this, a nice, symmetric bell curve. And when data is perfectly balanced like this, the mean and the median are exactly the same. They both land right at the center peak.
But our classroom, yeah, it looked more like this. It's got that long tail stretching way out to the right, all because of that one high outlier. We call this a right-skewed distribution. And whenever you have this shape, that outlier will always pull the mean so it's higher than the median.
And just so you know, this works the other way too. If we had a really young outlier, we'd get a left-skewed distribution. The long tail would be on the left, and that outlier would pull the mean down, making it less than the median. Here's a great rule of thumb. The mean always follows the tail.
So what's the big takeaway here? What does this mean for you in the real world? It means you now have a powerful new toolkit for looking at data. You know that you can't just blindly trust the word average. You have to ask which kind of average they're using.
So think of this as your quick cheat sheet. The mean, it's great when your data is all nice and neat without any crazy outliers, but its big weakness is that those extreme values can pull it all over the place. The median is your go-to tool when the data is skewed, for the simple reason that it isn't affected by outliers. And the mode is really just best for finding what's most common, but it often doesn't give you a true sense of a center.
All right, so if you walk away with just a few things, let it be these. First, the word average on its own can be super misleading. Second, always be on the lookout for outliers because they have a magnetic pull on the mean. Third, the median is your best friend when things get skewed. And finally, it's the shape of the data that really tells you what's going on.
So from now on, when you see a headline about the average salary or the average price of a house, you'll notice stop and ask, wait, which average are you talking about? The mean or the median? Because if there are a few billionaires or mega mansions in the mix, that difference changes the entire story. Now that you know the secret, what average will you question next?